Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series. So yes, today as we all know, today is Sunday and we have already launched our test series 2, that is of your KPL, KCET Premier League. So now it's time to discuss the questions, the solutions, okay. So yes, this time in the test 2 the portions were chemical kinetics, solutions and electrochemistry. So out of 30 questions, 20 questions were from chemical kinetics, 5 questions from solutions and 5 questions from electrochemistry. So I hope all of you would have attempted the question paper, would have downloaded from our WhatsApp channel or from the community post and would have solved it under exam conditions honestly, right? So now what you have to do, you have to see the solutions and then you have to give yourself mark. So if your answers are correct, assign +1, and if your answers are wrong or if you haven't attempted the question, assign yourself 0 marks and then comment down your scores, okay. So now without any delay, let's get started. So the first one here, the question is from your chemical kinetics. For a chemical reaction A2 products, the rate of the reaction doubles. The rate of the reaction doubles when the concentration of A is increased by 4 times, okay. So first we'll write the general formula, R is equal to K into A to the power of N, right. Now the rate of the reaction doubles when the concentration of A is increased by 4 times, okay. So now if you see that K is equal to, rate is becoming double when the concentration has been increased to 4 times, okay. So now this is my equation 1, this is equation 2, let us divide both of them. So 2 by 1 if I get, equation 2 divided by equation 1, right. So what I'll get, 2r by r, that is 2, and then I'll get 4 to the power of n, right. I'll cancel everything, we'll get 4 to the power of n. So I can write 2 is equal to 2 to the power of 2n, right. So now if I solve it, 2n is equal to 1, so n is equal to half. So the order of the reaction is half. Correct answer for this question will be option number C, okay. So yes, so I got the answer here, that is n is equal to half. Clear? Now coming to the next question, which of the following reaction is a zero order? So you know zero order, photolytic reactions are zero order reaction. So you can see this is a photolytic reaction. So the correct answer for this question will be option number B. Now question number 3, which of the following statements is incorrect? Okay, be very careful about correct or incorrect. Incorrect about the order of a reaction. Okay, what are the statements that is given about the order? Order of the reaction is determined experimentally, right? We do experimentally only, it is determined. You do the reaction, you change the concentration and then you observe what is the change in the rate. So yes, this is a correct statement. Next, it is the sum of the powers of the concentration terms in the rate law expression. Suppose I write R is equal to K into A and then B square, right. Then what is the order of this reaction? Order is 1 plus 2, that is 3. So that is the sum of the power of the concentration terms. So this statement is also correct. It does not necessarily depend on the stoichiometric coefficients. So order may or may not be equal to stoichiometric coefficients. So this statement is also correct. Next, order of the reaction cannot have fractional value. This statement is wrong because order of the reaction can be half also, can be any value, can be negative, positive, 0 or half or fractional, right. The correct answer for this question will be option number D, okay. Fine. Now coming to the next question, ethyl acetate is hydrolyzed in alkaline medium, okay. Its order of the reaction and the molecularity are respectively. So if you take ethyl acetate, okay, ethyl acetate, so this is an ester, right. If you hydrolyze it in the basic medium, alkaline medium, so what I will get, ethyl alcohol and ethanoic acid, okay. So this is the reaction between ethyl acetate and the base, okay. So here the rate I can write, rate is equal to K into concentration of ethyl acetate, C2H5 COO C2H5, okay. Sorry, I wrote the formula wrong here, 1 second. Yeah, so we will get CH3 COO C2H5 and then OH minus. Okay, so now if you see that the order here, it is 1, so the total order is 2 and 2 species are reacting, so molecularity is also 2, right? The correct answer for this question will be option number D, right? So here I can write order is 2 and here I can write molecularity is also 2. Okay, so now if I'll give you one question here, that is a homework question. So in the test also one homework question is assigned. So if this reaction would have been taken place in the acidic medium, okay, if the reaction has taken place in the acidic medium, then what will be the order and what will be the molecularity? Order and molecularity you need to tell in acidic medium. Okay, so answer in the comment section. Okay, I want all of you to answer this question in the comment section. Okay, next, the decomposition of H2O2 by I minus ion is believed to occur through the following elementary steps. Okay, next, the rate law of this reaction is, so we know that rate law depends on the slowest step, right? Rate law depends on the slowest step. So here this is the slow step. So what are the reactants here? H2O2 and I minus. So the rate will depend on H2O2 and I minus. So the correct answer for this question will be option number A. Okay. Now coming to the next question. Okay. Consider the data given below for the hypothetical reaction A to X. The time is given and the rates are given. Okay. So now you see with time, okay, with time there is no change in the rate. The rate is constant. Right. So with time what will happen? When time goes, reactant concentration will decrease. With the decrease in reactant concentration, according to the data, rate is constant. Right, almost you can see 1.6, 1.6, 1.6, 1.59. So rate is constant. Now what does that mean? Rate is independent of concentration. Right, so that happens in which order? That happens in 0 order. The correct answer for this question will be option number B. Next, the inversion of cane sugar is represented by this. It is a reaction of. So we know inversion of cane sugar. There are two examples. One is your acid hydrolysis of esters, and inversion of cane sugar comes under pseudo first order reaction. Okay, so the correct answer for this question is option number C. Next, the rate of a gaseous reaction is halved when the volume of the vessel is doubled. The order of the reaction is. Okay. Now let us write the equation. R is equal to K into A to the power of N. Okay. Now remember, when volume decreases, concentration increases. And when volume increases, concentration decreases. Okay. So now if you see here, the volume of the vessel has doubled. That means concentration will become half, and at that time the rate of the reaction is also becoming half. So I can say K is equal to A by 2 to the power of N. Now this is equation 1, this is equation 2. So what we have to do? Divide equation 1 and by 2. So 2 divided by 1. Okay, so what I'll get? R by 2 by R is equal to K will get cancelled, 1 by 2 to the power of N. Okay, so just we can write here, if I solve this one, I'll get 1 by 2. So you can see this is N is equal to 1. So the order of the reaction is first order. Okay, the correct answer for this question will be option number B. Okay, next, okay, now see, the oxidation of oxalate ions by MnO4 minus in acidic medium is given by the reaction. I hope the reaction is visible, or I'll write it again here. 2MnO4 minus plus 5C2O4 minus 5C2O4 minus plus 16H plus is giving you 2Mn2 plus, okay, plus 10 CO2 plus 8 water. Okay, so now the question is, the rate law is given to you. Rate depends on MnO4 minus and C2O4 2 minus. The order of the reaction with respect to H plus. So you see there is no term here H plus, that means H plus is not affecting the rate of the reaction. So the order of the reaction with respect to H plus will be 0. So we can eliminate this option. We have 0 here, 0 here, 0 here. Okay, next. And the overall order is what? Addition of the sum of the power of the concentration terms. So here 1, here 1. So overall order is, that is 1 plus 1, that is equal to 2. So 0 and 2, right? So correct answer for this question is option number D. Next, see, the rate of a reaction with respect to ammonia for N2 and 3H2 gives 2NH3 was found to be this much. This question is very tricky. If you have not understood the concepts properly, it is, see what it is saying, the rate with respect to ammonia, the rate of the reaction is 2 into 10 to the power of minus 2 into 10 to the power of 4. Okay, now the question 10 to the minus 4. Okay, sorry. Now the rate of the reaction expressed in terms of N2 and H2 are. So now remember, whether you express in terms of N2, H2 or NH3, okay, rate of the reaction is always same. Rate of the reaction remains same. Rate of the reaction remains same. Okay, it will not change whether it is in terms of N2, H2 or NH3. So if the rate is in terms of NH3 is 2 into 10 to the power of minus 4, it will be same for N2 and H2 also. The correct answer therefore will be option number, here also 2 into 10 to the power minus 4, here also 2 into 10 to the power of minus 4. The correct answer is option number D. Had the question been asked about the rate of disappearance of H2, rate of disappearance of N2, then you need to use the differential equation and do the calculation. But here it is asking the rate of the reaction, right? What is the rate of the reaction? Rate of the reaction will always remain the same. Okay, fine. Next, question number 11. Okay, for the reaction 2A plus B gives product, the following initial rates were obtained at various initial concentration. So 0.1, 0. These values are given. Rate law for the reaction is, okay. So now we know that rate law can be written as K into A to the power of X and B to the power of Y. Right? So now first we need to find the X value or the rate with respect to X. So for calculating A value, B should be constant. So which two reaction we can take? These two reaction where B is constant. So here what we are doing to the concentration, it is doubled, right? And here what is happening? It is becoming 4 times, right? So when you are doubling the concentration and rate is becoming 4 times, then it is second order reaction. If you are doubling the concentration, rate also doubles, it is first order. You are doubling the concentration, rate become 4 times, then it is second order. So I can say that X is equal to 2, right? So from here you can see the A, this value, this is eliminated, this is eliminated. We have these two options. Now let us see for B. So to check for B, A should be constant, so we will consider these two reactions where A is constant. Now if you see here to here, what is done? Multiplied by half, and if you check here to here, this is also half. You have half the concentration, rate has also become half. You have decreased the concentration by half, rate has also become half. Then this is first order reaction. So I can say that with respect to B, it is first order reaction. So here we can eliminate because it is 0. Correct answer will be option number C. Okay. Next, question number 12. So the graph is given, the order of the reaction as predicted by the graph. So if you see here, log term is there, right? Log term, if you see, you can blindly say it is first order reaction. The correct answer will be option number C. Okay, fine. Next, coming to question number 13. Yes, this is important question. Okay, so this is important question. Okay, so now see, at 100 degrees Celsius, the gaseous reaction A gives B plus C is found to be first order. Okay, so it is a first order reaction starting with pure A with the initial pressure of 120. If at the end of 10 minutes the total pressure of the system is 176, the rate constant of the reaction is, okay. So see, suppose I have given, reaction is given to us like this, A gives B plus C, okay. Now initially when time is equal to 0, there will be no B plus C, only A will be there. What is the pressure at that time? 120. Okay, now here 0, 0. Now after 10 minutes, when T is time 10 minutes, some amount of A will be consumed. So 120 minus X. X amount of A has been consumed. So how much A is left now? 120 minus X. Now you see 1 mole of A is giving you 1 mole of B. So X moles of A will give you X moles of B. So B produced will be X, C will be X, right? Now if I want to calculate the P total will be what? Addition of these two. So 120 minus X plus X plus X. So that is equal to, what is the total pressure given to you? Total pressure is 176. So I can write like this. So that equals, X will cancel, 120 plus X. So X is equal to 56, right? Now if you see, what is pressure of A after 10 minutes? After 10 minutes, pressure of A is this one, 120 minus X. I can substitute now 120 minus 56, that is equal to 64, right? So now what happens? We need to, so it is a first order reaction. We can use the integrated rate law for the first order reaction. So what is K value here? 2.303 by T is 10 log of A naught by A or P naught by P. What is the P naught value? Initial pressure 120, right? And final pressure P is 64. Now if you solve this, we will be getting 0.0628. Okay, correct answer for this question will be option number C. Okay, now coming to the next question. Okay, the 99% of a first order reaction was completed in 32 minutes. When will the 99.9% of the reaction gets completed? Okay, so this is also a little lengthy question, but first order reaction. So see, we can use the first equation, K equal to 2.303 by log of A naught by A. So 99% means 100 by 1, I can say. 99% was already completed, right? So how much will be left now? 1% is remaining. For that it is taking 32 minutes. Right, so I can write that K is equal to 2.303 by 32. Okay, now what it is asking, what is the time required for 99.9% of the reaction? Okay, so let us calculate. So for T 99.9%, I have K value, I have this formula, right? 2.303 by K log of 100 by 99.9. Sorry, 99.9 is, one second, okay, here 2 will be there, right? 10 to the power of 2. So this is, one second, yeah, so this is log 100, that means 10 to the power of 2. So I'll get 2 here. Okay, so now it is 99.9% is completed. That means how much is remaining? 0.1 is remaining, right? So that means I can write down this as 2.303 by, for K value we'll substitute this one. Okay, we'll not solve it, so I'll just cancel this one, 2.303 by 16. So I can write 2.303 by 16 log of 10 to the power of 100 by 1000 means 10 to the power of 3. So we will get it as, this will get cancelled, 16 3s are 48. The correct answer for this question will be option number D. Okay, correct answer is option number D. Okay, next one. Question number 15. The half-life of a first order reaction is, okay, what is the half-life of first order reaction? 0.693 by K, right, for first order. Okay, so now if you see 0.693 K, it is independent of initial concentration. There is no T half value for first independent of initial concentration. So correct option number A. Then first power of initial concentration, no. Second power, none of this. So correct answer is option number A. Okay, very simple theoretical question. Next, a first order reaction takes, first order reaction takes 25 seconds of the for the concentration of a reactant to decrease by 1/2, okay, of its initial value. So suppose it is 1 initially, now to become half it takes 25 seconds. Okay, now the time taken to decrease to 1/8 of its initial value. So see, first order reaction means the half-life is independent of the initial concentration. So 1/2 to 1/4, 1/4 to 1/8. So this will also take 25 seconds, this will also take 25 seconds. The total time here is 75 seconds. Right? Correct answer is option number C, that is 75 seconds. Okay. Next, question number 17. Okay. For a certain reaction, it takes 10 minutes for the initial concentration of 1 moles per liter to become 0.5. So 1 to 0.5, okay, it takes 10 minutes. Next, and another 10 minutes to become 0.25. So to become 0.25, it takes another 10 minutes. The above data indicate that the reaction is off. So now if you see that the half-life, here what we can say, the T half is independent of initial concentration. Now where we can find this type of thing? It is independent of initial concentration in case of first order. So we can say that this reaction is first order. Option number A. Okay, first order. Okay, next question number 18. Okay, so an endothermic reaction A to B has an Okay, an endothermic reaction A to B has an activation energy of 15 kilocalorie per mole and the energy of the reaction is 5 kilocalorie per mole. Okay, so what is given? Activation energy is 15 kilocalorie per mole, and then energy of the reaction, I can say enthalpy of the reaction is 5 kilocalorie per mole. The activation energy for the reaction B to A. Okay, so now if you see here, this is there. Okay, so now this is A, okay, and this is B. Okay, so now if you see, okay, now sorry, I draw the diagram wrong here. You see endothermic reaction. Endothermic reaction means the energy of the products will be more, right? So the graph will be like this. Okay, now see, from the starting point to the threshold region, this is the activation energy, which is 10. Okay, according to the question, this is 15. The activation energy given to you is 15, right? So we'll make it 15. Now, what is the energy of the reaction? The energy of the reaction is the energy of products minus reactants, right? This gap. So this is your, I can say that this is 5. Okay, this is total is 15, this is 5. Now what happens? This, so the question now asked is the activation energy for the reaction B to A. From going from B to A, what is the activation energy required? So you can see the total is 15, this is 5, so this value will be, B to A will be 10. Okay, the correct answer for this question will be 10, that is option number C. Okay, fine. Now coming to question number 19. In the figure, which of the following represents the slowest step? Okay, now slowest step means what? The activation energy should be very high. So how to find out? Slowest step is that where the activation energy is high. Okay, so now if you see from this part, this is having highest activation energy, right? Here you can see that this is very small activation energy, this is a very large activation energy, so process will be very slow here. The correct answer for this question will be option number C. I hope all of you are getting things and you must be getting the answers correct here. Okay, next coming to question number 20. For the reaction 2SO2 plus O2 gives 2SO3, the rate of disappearance of O2 is given. The rate of appearance of SO3. Okay, so first thing is we need to write the differential equation. So the reaction is 2SO2 plus O2 gives 2SO3. So if I write the rate of differential equation, minus 1 by 2 of dSO2 by dt is equal to minus dO2 by dt is equal to 1 by 2 of dSO3 by dt. Okay, so now what we can do? We can do, the question is given us rate of disappearance, dO2 by dt is given, we need to find rate of appearance of SO3, right? rate of appearance of SO3. So I can say that dSO3 by dt, can I write like this, is equal to 2 times of dO2 by dt, right? So that is 2 times of dO2 by dt is how much? 2 into 10 to the power of minus 4. So that will give me 4 into 10 to the power of minus 4. The correct answer for this question will be option number B. Okay, fine. Next, coming to question number 21 here. Okay, the vapor pressure of, so now we have completed kinetics questions, so we'll revise what we studied previous week, right? Solutions and electrochemistry. So 5 questions from solutions and 5 questions from electrochemistry. Okay, the vapor pressure of the benzene at 30 degrees Celsius is 121.8 mm. So vapor pressure, then when 15 gram of non-volatile solute is dissolved, 250 gram of benzene, its vapor pressure is reduced to this much. So this is relative lowering of vapor pressure, right? So what is the vapor pressure of pure benzene? That is P naught is 121.8. What is the pressure of the benzene after adding solute? It is 120.2. okay. Then non-volatile solute, okay, non-volatile solute added is how much? 15 gram, okay. And then benzene, the, I can say, mass of the solvent, mass of solvent, that is 250 gram, okay. So we'll get this. Now if I want to calculate that P naught minus P by P naught is equal to XB, right? So what is the value of P naught? 121.8 minus 120.2 divided by 121.8 is equal to XB. We can write that NB by NA, right? We have discussed, if in very dilute solutions, in the denominator we can ignore the number of moles of solute. So I'll write only NB. So NB will be what? NB means mass of the solvent, moles of the solvent. So 15 by molar mass, which I don't know, we need to calculate, and mass of the solvent, sorry, number of moles of the solvent. 1 second, yeah. Number of moles of the solvent will be equal to what? 250 by the molar mass of benzene. Molar mass of benzene is 78, right? 78. Okay, so now if I solve this, what I'll get? NB is 15 by M, okay, and this is 250 by 78. Okay, so just we need to, if I subtract this, I'll get 1.6 by 121.8. okay, then 15 into 78 by M into 250. okay, so now if I solve for M, I'll get 15 into 78 into 121.8 by 250 into 16. So I multiplied this one here and this one here, right? So now if I solve this, you will be getting around 356 point something. Correct answer for this question will be option number B. Okay, clear? Okay, next, coming to question number 22. If a 3.42 solution of cane sugar, molar mass 342, is isotonic with 1.52% solution of thiocarbamide, then the molecular weight of thiocarbamide is. Now what is isotonic solutions? Isotonic solutions means osmotic pressures are equal. Osmotic pressure is equal, right? Now there are two solutions, 3.42% cane sugar and 1.52% of thiocarbamide, and both are having same amount of we can say osmotic pressure. So I can write that pi 1 is equal to pi 2. Osmotic pressure is represented by pi. So I can write C1 RT is equal to C2 RT, right? This is R. So RT I can cancel. C1 means what? Molarity. Molarity is again number of moles. Then the unit amount of volume is again same. So I can write that given mass 3.42 by molar mass is equal to 1.52 by the molar mass. So if I solve this, you can say I'll get here 1 by 100, right? And molar mass 1.52 by M. So I'll get M is equal to 152. The correct answer for this question will be option number A, right? So very easy calculation. Fine. Now coming to the next question. Okay, a substance is completely dimerized on the dissolution in a solvent. The Van 't Hoff factor is, okay. So now if you know the Van 't Hoff factor, how to calculate? Number of particles after association or dissociation divided by number of particles before association or dissociation, right? So now what is happening? It has undergone dimerized, means two particles became one particle. So that is the number of particles. If earlier it was 2, now it has become 1, right? So I can say that number of particles of, suppose 2A was there, okay, now it became A2. So what is the number of particles after the reaction? That is 1, and the number of particles before were 2. So what is I value? I value is 0.5. The correct answer for this question is option number D, okay. Now coming to question number 24, the degree of dissociation alpha of a weak electrolyte AXBY is related to Van 't Hoff factor I by the expression is. So if you know, for dissociation alpha is equal to I minus 1 by n minus 1. What is n here? Number of particles produced. Now if AXBY is there, how will it dissociate? X times A and Y times B, right? X times A plus and Y times is the total number of ions. N is equal to what? X plus Y, okay. So now if I want to get here, alpha is equal to I minus 1 by X plus Y minus 1, right? So what I'll get? I minus 1 by X plus Y minus 1. The correct answer for this question will be option number B, right? Okay, so this is my answer. Next, so let us see the next question here. A 75.2 gram of C6H5OH is dissolved in 1 kg of a solvent of KF14. Okay, if the depression in freezing point is 7 K, then find the percentage of phenol that dimerizes. Okay, so first of all, there is depression in freezing. So what is that? Delta TF, I can write the formula, is equal to I into KF into M. Okay, now what is delta TF? That is 7. Okay, I value we need to calculate. KF value is 14. Molality, if I want to write, what is the given mass? 75.2. Okay, then what is the molar mass? Molar mass of the phenol is 94, right? 94 into 1 kg. Okay, so now if I calculate this one, I will get I value as, if you see, we can cancel 7 ones are 7 twos are, then I have here 2 into 47, right? So 75, so I value will be 47 by 75.2, right? So this value will be getting around 0.625. Okay, I value will be equal to 0.625. Now coming to alpha value. Alpha value will be equal to I minus 1 by n minus 1. Okay, now if you see dimerizes means what? N value is half, right? So now I can substitute 0.625 minus 1 by 1 by 2 minus 1. So that is equal to, if I solve this, we will be getting around 9 minus 2, 7. Then I'll have 0.375. Okay, then I have minus 0.375 and I have here minus 1 by 2. So if I take this and I multiply, I'll get 70.75. So if we consider to percentage, it will be 75%. Okay, correct answer for this question will be option number C, right? 75%. Okay, now next question, coming to electrochemistry. So 2 platinum wires were dipped in copper sulfate solution, taken in a beaker and then connected to a battery. So we have like this. This is a solution. Here 2 platinum electrodes are there. Okay, and then it is connected to copper sulfate solution. Okay, Now the blue color of the copper sulfate disappeared. The blue color of the copper sulfate disappeared and a gas was found to be evolved at one of the electrodes. The solution in the beaker contains what? Now see, copper, this is your positive, this is negative side. Now copper is copper 2 plus and we have copper solution taken into beaker, and then constant solution means water will also be there. So we have H plus, we have sulfate ions and we have OH minus, right? So if you know, remember copper reduction potential is more than hydrogen, right? So what will happen? Copper will undergo reduction here and OH minus will undergo oxidation here, right? So what will happen? This copper 2 plus will go here and OH minus will come here, right? So what will be the reactions? If you see, this is my anode and this is cathode. So at cathode what reaction takes place? Copper 2 plus plus 2 electrons giving you copper, and the reaction taking place at anode is OH minus, right? 2 OH minus giving you this will release, so I'll get O2 plus 2 electrons plus 2 H plus, right? So now if you see here, O2 gas is produced and copper is released. Now what is remaining in the solution? We are not worried about this because question has not asked here. In the solution we have H plus and SO4 2 minus. So this one will react to give you H2SO4. So what does the solution contains now? That is sulfuric acid. Correct answer is option number C. Okay. Next, coming to the next one here. Okay. Now, a certain quantity of electricity is passed through an aqueous solution of AgNO3 and copper salt solution connected in series. The amount of Ag deposited is 1.08 and the amount of copper deposited is. So this is your question from Faraday's second law, right? What does Faraday's second law say? What is the formula? M1 by M2, okay, is equal to E1 by E2. Now how to calculate equivalent weight? Equivalent weight is molar mass by N factor. So it is asked for copper, right? So I can say that mass of copper deposited by mass of silver deposited. How much silver is deposited? 1.08 is equal to equivalent weight of copper. Equivalent weight of copper means how will copper Cu2 plus 2 electron is equal to copper. So what is the N value for copper is 2, right? So I can write equivalent weight of copper as 63.5 by 2. Now if you consider the silver, silver is what? Ag plus 1 electron is silver, right? So for N value for silver is 1. So again, what is the equivalent weight of silver? Molar mass by N factor, that is 108 by 1, right? So now if I solve for this one, mass of copper will be equal to 63.5 by 2 by 108 by 1.08. This one I'll take this side and I'll multiply. So what I'll get? If I solve this, I'll get 0.317. The correct answer for this question will be option number C, that is 0.317. Clear? Okay. Fine. Now coming to question number 28. The equivalent conductances of NaCl, HCl and C2H5COONa at infinite dilution are given to us. So first let us note down these values. For infinite dilution for NaCl, then I have for HCl, and next one is for C2H5COONa. So NaCl value is how much? 126.45. Okay, HCl value is how much? 426.16, and the salt value is how much? 91. Okay, so now I want to calculate according to question. It is C2H5COOH. Okay, so now I see we want this part and this part, right? So from where I'll get this ion I'll get from this one, right? From where I'll get H, I'll get from this one. Now when I add these two, the extra thing that is produced is NaCl, so I have to subtract this one. So what I need to add 91 plus 426.16 minus 126.45. So if you solve this, we'll be getting around 390.71. Okay, so correct answer for this question will be option number B, that is 390.71. You can do the calculation and check by yourself. Okay, so this is the answer here. Okay, now coming to the next question here, E1, E2 and E3 are the EMF of the following three galvanic cell. Okay, so now you need to tell me the order of this one. So if this is the cell, okay, Zn is undergoing oxidation, copper is undergoing reduction. So what I'll get, Zn is undergoing oxidation, 2 plus 2 electron, and copper is undergoing reduction. Right, so now if I add these two reaction, what will be the reaction that I'll getting? Zn plus Cu2 plus gives Zn2 plus Cu. Right, this will be the reaction. Now if I want to write the E value, then it is E0 minus 0.059 by N. N value is 2 here, log of Zn2 plus by Cu2 plus. Okay, so now if you see here, we need to put the concentrations value here. So for option number A, if I do, like option number not A, if I do for the first shell. Okay, so 1 second. Okay, so if I do for the first shell, okay, so I'll get E is equal to E0 minus 0.059 by 2 log of, what is Zn2 plus concentration? 0.1, and this is 1. So I'll get 0.1 by 1, which can be written as 10 to the power of minus 1. So I'll just solve here. This one I can now write as 10 to the power of minus 1. This minus 1 will come front. So what will be the E value? E0 plus 0.059 by 2. Right, now if I see option number C, like second cell that is given to me. So in this case, what is there? It is 1 by 1. So means this is 1 by 1, log 1. Log 1 means what? 0. So this term will become 0. So what is E value? E value is E0. Okay. Now if you see third one, in third one what is there? It is 1 by 0.1. Zn2 plus is 1. This is 0.1. So I'll get it as like this. E is equal to E0 minus 0.059 log of, this is 1, this is 10 to the power of minus 1, right? So if it goes up, it will become 10 to the power of 1 now, right? Now this one will be written as 10 to the power of 1, right? 10 to the power of 1. 1 comes here, so I'll get what value? E is equal to E0 minus 0.059. Okay, so now you see here, I'll be telling you the highlighting the values, then it will be more clearly visible. So the first one here is E0 plus something. Second one is only E0. Third is E0 minus something, right? So this is your shell E1, this is given E2, and this is E3. So you see now E0 plus something will be highest, then this one, then E0 minus something, right? So what will be the order? E1 plus E2, E1 is greater than E2, then E3. Okay, the correct answer will be E1, then E2, and then E3. Okay, so this is a very good question, concept good question. Okay, next coming to the last question of the test. The cell reaction is given to you, you need to, okay, the cell is given to you, you have to identify the cell reaction. So this is very simple question. So left side I told you lone, if you remember, left side it is oxidation. So copper is undergoing oxidation by giving you 2 electrons. And then we have mercury, okay, mercury is undergoing reduction by taking 2 electrons. Now if I add these two equations, this one will get cancelled. So I will get copper plus Hg2 plus gives copper 2 plus Hg, right? So we'll get copper plus Hg2 plus gives copper 2 plus Hg. Correct answer for this question will be option number D. Okay, so yes, so students, that was the end of the solutions discussion of the KPL2, and I hope all of you would have attempted the questions. Do not forget to comment down your scores. We need to check. Please, if you haven't attempted this test, I'll request you again, please go to the WhatsApp channel, join our WhatsApp channel, download the question paper and solve it. Okay, so it is very, very important to solve the questions so that you can measure your level of preparation. Okay, so yes, in the next class we'll continue with our lecture series. I hope all of you have understood all the questions. If you have any doubt in any question, do not forget to comment down. You can post your doubts in the comment section. I'll definitely address it. Okay, so yes, now thank you for watching and subscribe the channel for such more videos, and all the very best. Remember, we have to hit that perfect 60 score. Okay, thank you and keep smiling, keep studying hard. See you in the next episode of this series.